So in this problem, we are already given a picture that looks something like this. So we have the Starship Enterprise with mass m moving to the right with some velocity v sub e, and it is on a collision course with a Klingon ship of mass m over 2 with some unknown velocity little v. The two of them are going to collide, and then they're going to move off down and to the right at an angle of 30 degrees with the horizontal, with another unknown velocity, big V. And now what we're going to be solving for is little v and big V in terms of v sub e. Now in this problem, we're going to define our coordinate system a little bit differently. So we're going to define that down and to the right are going to be positive. And the reason we're going to do this is that when we split these up into components so that we can solve the equations, this is going to mean that all of our components are going to be positive instead of having a few negatives thrown in there to confuse our math. So just like in the other two problems, the first thing we're going to note is that this is an isolated system. And again, what that means is that the two things are isolated and nothing is interacting with them, which means that momentum is going to be conserved. So Pi equals Pf. And so now what we're going to do is we're going to first take Pi, which is just going to be the momentum of the Starship Enterprise plus the momentum of the Klingon ship. And so that's going to be m times v sub e times x hat plus, not minus, remember this is why we defined downward to be positive, plus m little v over 2 times y hat. And of course, P final is going to be a little bit more complicated, so we're going to have to use trig to find the x hat and y hat components for big V. And this is going to end up giving us, well, first of all, we have to sum the masses, since the two of them have stuck together. So we now have a mass of 3m over 2. And then we're going to get root 3 times big V over 2. So that's big V times the cosine of 30 degrees for x hat, plus 3m over 2 times big V over 2. And so that's going to be big V times the sine of 30 degrees times y hat. And so this time, because we don't have any unknown angles, so we don't have any trig functions in here, our big V and little v unknowns are separated, and we don't have to do a system of equations. We can just solve one equation at a time. So the first thing we're going to do is we're going to solve for big V by comparing the x hat terms. And so that's going to give us 3 root 3 over 4 times m big V equals m times v sub e. And now all we have to do is we cancel the m terms, and we end up getting big V, and we pull this over, equals 4 over 3 root 3 times v sub e. So right away we have one of our solutions. Now all we have to do is we take the y hat terms, and we are going to plug in our value for big V to solve for little v. So that's going to give us m times little v over 2 equals 3m times big V over 4. And pulling this over, we get little v equals 3 times big V over 2. And then we can plug in the solution that we already got, and that's going to give us little v equals 2 over the square root of 3 times v sub e.